Okay, here we go. So I will have a video of about half the questions and then a second video for the second half of the questions. So you can fast forward and see the answers if you want to. If you miss a problem and want to know how to do it, then I guess you slow down and hopefully can understand what I'm doing on the video. Okay, number one is solving the systems, and we do so by elimination. And really on these, there's not one way to do it. So it's just what stands out to you. So the idea is to pick two of the three equations that the variables, so you could pick the x's, you could pick the y's, you can pick the z's. But the idea is that they are the same number and one's a positive, one's a negative. Okay, so I have my route that I'm going to do, but somebody earlier today chose to get rid of the y's, because notice the y's were both 3, but one of them needed to be a positive 3, the other one needed to be a negative 3. So they just distributed a -1 through one of them and got rid of the y's, and they started there. Okay, I'm not going to, because I noticed that these two have the same number and the opposite sign. Okay, so for right now, I'm just looking at these two equations. Okay, so just these two. So I can cross off the z's, right, because they eliminate each other. +5, -5 gives me 0. So now I'm just combining what I have. So I have a +2x and a +5x, which gives me 7x. -3 and a +5 gives me a +2y. And then adding what is over there, which is 36. Okay, so I've got one of them eliminated down to 2 variables. So now I need to do that same thing to the one that's left over. Okay, so I got rid of the z's. So that means in that equation I have to get rid of the z's. So I pick one of these, either this one or this one. It does not matter. It's just what stands out to you, but it needs to be the same number, and one needs to be a positive, one needs to be a negative. So I chose to combine with that one, this one. Okay, and the only reason why I picked it is because of the positive and the negative. That was already there. Okay, so to get rid of the z's, when I'm looking at those two, they need to be the same number. So in order to make them the same number, I would have to multiply this one by a 5, so that I would get 5's either. So when I put a 5 here, I'm going to distribute this to everything in this equation. Okay, and I'm going to write it off to the right-hand side. Okay. Okay, so this would give me 20x minus 15y plus 5z equals, and then 5 times 34, there it is. Okay, so that was distributing that 5 through. Okay, so now I'm just bringing this one over, because that's the one that I chose to combine it with, because the z's were the opposite. One's positive, one's negative, same number. Okay, so I'm just rewriting it off to the side, because I didn't have to change that one. It already had what I was looking for, which was the 5z. Okay, and so now when I do those, I'm able to get rid of the z. Okay, so this gave me 22x minus 18y equals 186. Okay, so now you're going to join that one with this one. Okay, so I have 2x minus, which is your first one that we did, 18y equals 186. Okay, so now I'm only looking at these two. So now I just decide, and again, it does not matter. You could choose the x's to get rid of or the y's to get rid of, but they need to be the same number, and one needs to be a positive, one needs to be a negative. Okay, so what stands out to me is the positive, negative here. I already got that. So I need them to be the same number. So you just think of the smallest number that 2 and 18 could go into. You could pick 36 if you wanted to, which wouldn't be the smallest number. But really, all I need to do is change this one, the red one. Okay. All I need to do is multiply this by 9, because if I distribute 9 to 2, it's going to make it a positive 18, and this one's negative 18, and that's what I want. So I'm distributing this to these, and I'm just going to write it down below, okay, so that I can combine it with that 22x minus 18y. Okay, so when I distribute that, that's going to give me 63x plus 18y equals 324. Okay. So I'm not looking at that guy, the red one, anymore. Okay, so now I'm looking at these two. Okay, so the y's cross cancel. Okay, now I've got 22x plus 63x, which would give me 85x. Okay, and then the 186 plus the 324 gives me 510. Okay, so then I would divide, and x would be equal to 6. Okay, so now you just go back to your equations, not the XYZ equations, just the XY equation. And where there is an X, you're going to plug in a 6. So the smallest one is the one I always pick. It doesn't matter. You could have plugged it into this one, or you can plug it into this one, but I would rather have a smaller number to plug it into. So I'm going to plug it into the red one. So where the X is at in the red equation, I'm going to plug in a 6. So I'm going to go 7 times 6 plus 2y equals 36. So now all I have is a y to solve for, okay? So when I go 7 times 6 would give me, did I do that right? Yeah. Yeah, I did a different one in my notes. Okay, 7 times 6 is 42. And then I'd have 2y equals 36. Okay, then I would move the 42 over, okay? And then the last step, that would give me a negative number, then I would divide by 2. So my y would give me a negative 3. Okay, then from there, so I have an x and a y, so now I need to solve for the z. So you just choose one of your equations to plug back into. Any of the black ones that I have on the screen where there's an x, y, and a z. So you can just replace the x with a 6, the y with a negative 3, and then solve for z. So I'm going to extend my page. Okay. And I plugged it back into the very first one, so the 4x minus 3y. Okay. So 4 times 6. Okay, then I have the negative 3. Now for the y, I'm going to plug in a negative 3. Okay, and now all I have left is to solve for the z. Okay, so 6 times 4 would give me 24. A negative times a negative gives me a positive 9 plus z equals 34. I would combine these two, so 9 and 24 gives me 33. Okay, so then I'd subtract the 33 from the 34, so then my z is 1. Okay, so there are my 3 answers. Okay, moving on to the next one. Okay, number 2. So anytime you see quadratic equations, you need to factor them down. So this is multiplying with fractions. And multiplying with fractions, we like to simplify, but you have to factor them down so that you know what the simplest form is. Okay, so this top one we need to factor down, this bottom one we need to factor down, okay, and then this one, the only factoring we can do is take out a common factor, so I'm going to do that one first, okay, which would be b plus 4. This one here, notice that all of these, when we go to factor these, so like this one, these are first, okay, so we want the v to be first in this one. So to do that, we rewrite it by writing a negative 1 on the outside. And then that would switch this now from a negative 4b squared to a positive 4b squared, and this positive 25 to a negative 25. Okay, now I just made it a perfect square binomial. Okay, so when I go to factor this, now I can break it into 2 parentheses. One's plus, one's minus. Square of 4 is 2b. Square of 25 would be 5. Okay, so now the only one I have left is that top one up there. Okay, so signs are different. So one's a plus, one's a minus. My factors of 2 are 1 and 2, and split up by these. And then my factors of 20 are 1 and 20, 2 and 10, 4 and 5, but I know that I'm cross-canceling, so I'm going to pick the 4 and 5, because that's what we have in all of these, okay, is a 4 and a 5. Okay, so sometimes you just have to plug check. Okay, so I'm going to put the 4 here and the 5 here. So if I were to check that, that's going to give me a negative 5b and a positive 8b, which that gives me a positive 3b, so I need to switch my signs, okay? So I'm going to switch this and this one to a negative. So now, when I distribute, that gives me a positive 5b and a negative 8b, which gives me a negative 11. Okay, so now that they're all broken down, we're looking for anything on the top with anything on the bottom that you can cross-cancel with, okay? They have to be same thing. Okay, so I could do this b plus 4, and b plus 4, 2b plus 5, 2b plus 5, and there's nothing else left. Okay, so what's left on the top is 5b, and then you have the b minus 4. Okay, and then on the bottom you have this, this, and this. Okay, so the negative 1, and then you have the 2b minus 5, and then the b plus 5. Okay, don't put them back together, because if you put them back together, you're more apt to make mistakes of distributing something wrong. So just leave it like that. Okay, number 3. Okay, number 3, multiple ways you could do this one as well. You can combine and multiply the top numbers, the numerators together, and put them together, which 45 times 7 would give you a really big number, and then you'd have x, y squared. And then on the bottom, you'd go 9 times 15 and have a really big number with a y. But then from there, you'd have to simplify, okay? So that would make it more difficult. So if you can simplify with smaller numbers, it makes it easier to begin with, okay? So it's any top number with any bottom number that you're cross-canceling. So I'm not looking at the variables right now, I'm just looking at the numbers. Okay, so I could do, like, 5 can go into both of those and do that if I wanted to start there. I'm going to start with a 9 and a 45, because 9 can go into itself once and 9 goes into 45 5 times. Okay, but now I have a 5 and a 15. So if I had 5 over 15, that would reduce to 1/3. Okay, so 5 goes into itself, 15 goes into there. Okay, now the only thing that's left is this 3 and the 7, and they don't have anything in common that we can reduce. Okay, so that part of my equation is done. So the 3 and the 7 are going to stay. So now what I'm looking at is I have x, y squared on the top, okay, and a y on the bottom. So there's no x to cross cancel with, so that means that x is going to stay there. Okay, but the y's, we move the smaller to the larger and subtract. Okay, so that would make this y. So this is your answer right there, okay? Which again, you could have done this here, subtract that and made that a 1, and then just don't forget about that x. Okay, number 4. This is not adding and subtracting, so you cannot cross cancel, okay? We have to get a common denominator. So whatever's in one denominator has to be in the other one. Okay, so this one has 4 y's, but this one only has 2. So this means that this one needs 2 more, okay? Whatever we do to the bottom of our fraction, we have to do to the top of our fraction, okay? So now my y's match up, but now I'm looking at my z's. I have a z to the 5th and a z to the 2nd. This one's missing 3 z's, okay? So now when I put it there, there's 5, but whatever I do to the bottom, I've got to do to the top. Okay, at this point, once you got the common denominator, so the common denominator, now they both have y to the 4th, z to the 5th, is you look to simplify each numerator if you can, okay? Well, there's nothing in this numerator that I can combine, so it's going to stay the same, okay? There's nothing adding, subtracting, or anything. And I can't combine it with this numerator, okay? So we just write them as 2 separate things, okay? But they're still there. You just can't combine them together. And that would be your answer for that one. Whoa. Okay, next one. Okay, we've got factoring again. So I need to break this guy down and this guy down. Okay, and it's adding fractions. So I need to get a common denominator, but I have to break them down first. Okay, so I'm going to have my 2 parentheses. Okay, this ends in a plus, so it means the signs are same. Same what? This answers my question. So they're both going to be negatives. I split up my x's, and then I read backwards. What are my factors of 5 that add to give me 6? Well, only factors of 5 are 1 and 5. Okay, perfect square binomial ends in a negative, so it means that the signs are different. Split up my x's, and then the square of 25 is 5. Okay, so we need our denominators to be the same. So this one has an x minus 1, but this one doesn't. So that means I need to multiply whatever I multiply on the bottom. I've got to multiply on the top. Okay, so x minus 1, x minus 1, x minus 5, x minus 5. So it means that this guy over here is missing the x plus 5. Okay, so whatever I multiply on the bottom, I've also got to multiply on the top. Okay, so we have our common denominator. It does not matter the order of the 3 parentheses, just make sure you have those 3 parentheses. Okay, so an x plus 5, an x minus 5, and an x minus 1. Okay, so now what you're doing is you're going to simplify this numerator, And then simplify this numerator before you can combine the two, okay? So if I distribute this, that's going to give me x squared. That would give me 5x. That gives me a negative 6x, which is a negative 1x. And then a negative 6 times 5 gives me a negative 30. Okay, so now I'm doing the same thing to the other one. So x times x is x squared. I have a negative 1x and a positive 5x, so that would give me a positive 4x, and then minus 5. Okay, now combining my like terms, x squared, so I have two of them. Okay, then combining these two that are like terms, so a negative 1 and positive 4 is going to give me a positive 3x. And then these guys are my like terms, so negative 30, negative 5 is going to give me negative 35. Okay, and then you're done with that. Okay, next one. Okay, so this one, you can write them separately, you don't need to, but each one of these is being divided by 4x to 4xy, and then this is being divided by 4xy, and then this is being divided by 4xy. So if you want to write them as three separate fractions, you can, or just remember when you divide it, it's still there to go on to the next one, okay? So if I look at just these two right now, I'm going 8 divided by 4, which is 2. I went up to the top. Okay, and then now I subtract. So this one has a 1, this one has a 1. So when I move it up here, I'm subtracting 1 from each one of these. Okay, which would make it x to the second, y to the third. So now I do it again. Okay, but now I'm doing these two. Okay, so 12 divided by 4 would make it 3. And I'm subtracting and moving the smaller to the larger. Well, both of these are smaller. Okay, well, this one's staying. So that would get rid of that. But we're going to move that one up to that one. Okay, which is going to leave it just as a y. Okay, now for my last one, I'm going 4, so it's now these two. Okay, so 4 divided by 4 is 1. You can write a 1 if you want to. You don't have to. There's still variables there, so we know there's 1s in front of it. So x to the 1 coming up here, y to the 1 coming up here, so I just still have an xy left. Okay, and then that's your answer. Because none of those are like terms, so you cannot combine those together. Okay, next guy, number 7. Okay, long division. So on the first one, number 7, you get a remainder. The next two, we're going to factor down further. Okay, so anytime there's a remainder, you can't factor through. Okay, so what we're doing is making sure that everything is written in descending order. So if you look at your worksheet, it had 3x to the third minus 2x minus 9. So that meant that we were missing an x to the second. So we talked about when we did notes on these, you need place value. Okay, and it doesn't matter if it's a 0x or a minus, or positive 0 or a negative 0, because when you add and subtract 0, it's not going to change the number. Okay, so what we do when the pattern repeats is we go the first divided by the first. Okay, so this is 3x to the third being divided by x. So if I asked you to simplify that, that would give you 3x to the second. So whatever this answer is, you write this up at the top. Okay, so this is 3x to the second. Okay, now what you're doing is you're taking that number and you're going to distribute it back to what is on the outside. Okay, so distribute means to multiply. And then you're going to write it underneath this part right here. Okay, so I have 3x squared times x minus 2. So if I distributed that, it gives me 3x to the third. Okay, those should match every single time. If they don't, you did something wrong, go back. Okay, but now when I distribute 3x squared to the negative 2, I get a negative 6x squared. Okay, but we've got to eliminate. So that means I've got to switch this from a positive, switch. Okay, this goes away. I bring this down, which is 6x squared, and then I bring down the next one. Okay, now I'm going to repeat the process. It's the first being divided by the first. So 6x squared being divided by x. So if I asked you to solve that, you would write that now up at the top. So that would be 6x.
Staff, this is just a quick reminder that today is our ratification meeting. If you are a FTA union member, please make your way over to the middle school, room 27, in the West House classroom. We will be
now we're distributing the 6x back out to those. Okay, so the 6x goes back to the x minus 2. Okay, so that's going to give me 6x squared. It matches up. It's supposed to, remember. Okay, now 6x times a negative 2 would be a negative 12x. Okay, but you've got to switch switch. This goes away, this brings down 10x, and we're at our last step of bringing down our next one, okay? Same process, first divided by first, so 10x divided by x, so the x's go away, it's just going to leave 10. Okay, if I distribute 10 out to both of these, it's going to give me 10x, it matches, it's supposed to, and then 10 times -2 gives you -20, but we've got to switch, switch. This goes away, and then whatever you have left, if there's anything left, is your remainder, which I told you this one would, so 11. Okay, so we have a remainder of 11. Okay, so this is your final answer. Okay, the next two aren't going to have remainder, so it's actually going to wind up with 0, and then I'm going to show you how we're going to break them down further. Okay, so number 8, doing the same thing. Okay, so we're going this divided by this. Okay, so I'm going to not write it off to the side like I did on the first one. If you need to do that when you're doing the test, do that. But I've already got through and done this. Okay, so it's going to be x to the third. So when I distribute this back out to the side, I get 2x to the fourth, and then I get a negative x to the third. Okay, but remember we switch it, it was positive. We switch it and then switch it. So these guys go away. Okay, so that gives me 14x to the third, and then I bring down the next guy. Okay, so first divided by first. Okay, so that's going to give me a positive 7x to the second. Okay, when I distribute it back out there, it gives me 14x to the third, and then 7 times the -1 is going to be a negative 7x to the second. Okay, but I've got to switch, switch. Okay, that goes away. That comes down as 28x squared. Okay, and then I bring down the 2x. Okay, so first divided by first. So 28 divided by 2 is going to give you 14x. Okay, when I distribute it back, it gives me 28x squared. And then 14 times -1 is going to be a negative 14x. Okay, switch, switch. That goes away. Combine those two, which gives me 16x, and then that last one, which is a negative 8. Okay, so 16x divided by 2x is going to be 8. When I distribute the 8 back, I get 16x, okay, and then 8 times the -1 is a negative 8, but we switch, switch, okay, went away, there's no remainder, okay. Okay, so this is one of our answers, okay. From there, we're going to factor that what's up and at the top part, okay. So the long route would be to do this long division, okay. And you can do that. If that's the way that you remember, you can't remember how to do synthetic division, then don't do synthetic division, okay? But how we do it is we always look at our last number, okay? So here's my last number. So my factors of 8 are 1 and 8 and 2 and 4. Okay, so if you were going to do the long division, you would now write, which I'm not going to, but I'm just going to show you that you can do it that way. You would write the x to the third plus 7x squared plus 14x plus 8. Okay, and then we don't know if it's 1 or if it's 8 or if it's a positive or a negative. If it's a positive or a negative. Like this would take forever, okay, for you to do the long division. So I don't know if it's going to be an x plus 2, I'd have to do the division. If it didn't work and you got a remainder, then you would have to try the x minus 2 and then see if you get a remainder and do the long division. This would take forever. So I taught you how to do synthetic division, okay? So what you're doing is you're taking these numbers, okay, that you had as your answer, and we're just writing the numbers that are in front of them. So in front of the x third, there was a 1. In front of the x squared, there was a 7. In front of the x, there was a 14, and they were all positive numbers, so you write them as positive numbers. So if any of those were negative, then you would put negatives. Okay. I want to start with x plus 2, so I think it's x plus 2, okay? But when I write it on that synthetic division, I don't write it as a positive 2, I write it as a negative 2. And what this is this switching that we do every time. We're just going ahead and switching it. So it's not a positive 2, it's a negative 2. Okay, so what we do is we bring down our first number every single time, which is 1. Okay, now I'm going 1 times a negative 2, and it's a negative 2. Put that there. Now I subtract and bring down 5. Now I do it again. I'm going to go 5 times a negative 2, which is a negative 10. Bring that down, which is 4. 4 times a negative 2 is a negative 8, and I got 0. So that means there was no remainder. Okay, so that means x plus 2 works. So pretend if this was, and I distributed it, say it was a negative 4, and I distributed a negative 4 to a negative 2, got a positive 8, this would have given me 16 here, right? So that means I would have had a remainder. I didn't get 0 in the end. So that means then you wouldn't try x plus 2, you would try an x minus 2, okay, and distribute it and go again. But this is way faster than doing all of this every single time, okay? So because we did, okay, get 0, now all we have to do is factor what was left. So if you notice, when we started, we had an x to the 4th, right? And we divided and we got an x to the 3rd. So now we're dividing again and got where this was the x to the 3rd. Then that means this next one down is an x to the 2nd. Okay, so then we can write the rest of our equation and now factor this one. Okay, signs are the same. They're both going to be positives. Split up my x's, and then you read backwards. What are your factors of 4 that add to give you 5, which would be 4 and 1. Okay, so our 4 answers, okay, are 2x minus 1, and x plus 2, and then these guys right here. So you should have 4 parentheses. And you have 4 parentheses because when you started, it was x to the 4th, okay? So that's what tells you you're going to have 4 parentheses. Okay, next one, synthetic. Don't have to use synthetic for our next division one. That was the only one that was synthetic. Okay, you could actually use synthetic on this one if you wanted to start it with that way and flip it upside down, but you're still going to have to factor the next answer. Okay, so first divided by first, I get, first divided by first, I get 3x squared. Okay, when I distribute that back, I get 3x to the 3rd, and then I get a positive 6x squared. Okay, but I've got to now switch. These guys go away. Okay, I'm subtracting 6 from 16, which gives me 10x squared. Bring down my next one. First divided by first, which is going to give me a positive 10x. Okay, I distribute it to what's on the outside, which gives me 10x squared. Distribute it to the 2, which gives me a positive 20x, but I've got to switch. These guys go away. Okay, that's going to give me 3x, and I'm at my last step of bringing down to positive 6. Okay, so 3x divided by x is just going to be 3. Okay, when I distribute it back, I get a 3x plus 6, but I've got to switch. Goes away. So I know that this is a factor, which it tells you it's a factor, but now I've got to factor this one down. Okay, so to do that one, you can do the quadratic equation if you want to. This one can actually factor the old way. Okay, so signs are the same. They're both going to be positive. My factors of 3 go in this first position here. Okay, so my factors of 3 are 1 and 3. Okay, and then my factors of this one goes in my second position. Well, the factors of 3 again are 1 and 3. And you just need to make sure it's in the right spot. Okay, so when I check that, that gives me 1x, that gives me 9x, and 1x and 9x gives me 10x. So my 3 answers, because again, we had 3, okay, so we should have 3 parentheses, is going to be this one, and then my original one. So x plus 2, x plus 3, and 3x plus 1. Okay, moving on. Okay, so we're breaking down squares. So breaking down the radical, we do our factor tree. So breaking down 8 would be 2 and 4, 2 and 2. I'm looking for pairs because that's what squares mean. Okay, so that comes out, right? And then that one stays. So a 2 comes out, but a 2 is going to stay on the inside. Okay, and those are all my prime numbers that were left over. Okay, now when I look at my x's, okay, remember this is the same as going x times x. So that means I have a pair of them, there's none left over. Okay, so that means a pair comes out, just one x comes out. The other way we looked at it is whatever this number is, which for that one is squared, you just divide it by that. So 2 divided by 2 is 1, so that means only 1 comes out. So that's your answer for that. Okay, so if you're just listening to what I did here, we now have a 3 here. So instead of writing out x 11 times, x, and circle all of them, we can just divide it by 3 and divide this by 3 so that we know how many can come out and how many are left over. Okay, so obviously if there's a remainder in the numbers, then you're going to have something left on the inside. Okay, so when I'm dividing 11 by 3, 3 can go into 11 3 times. Okay, so that means I can bring out 3 of them. Okay, but there's going to be some left over. So 3 and 3 is 9, so I subtract that from 11, and that would mean that there's 2 of them left over. Okay, so 14 divided by 3, that can come out 4 times. Okay, which is 12. So 12 minus 14 would mean that you would still have 2 left over. Okay, breaking down 48. Okay, and again, you can start anyway. You can start with 2 and 24. I'm going to do 6 and 8. 6 is 2 and 3. 2 and 4. 2 and 2. Okay, so I'm looking for pairs. So I have a pair of 2's here and a pair of 2's here. Okay, so a 2 comes out, a 2 comes out, so that's going to make it 4 on the outside. But this guy was a prime number that was not taken out, so it's going to stay on the inside. Okay, but now we're going to divide, because this number out here, when there's not a number, it's a 2. I'm going to divide those guys by 2 to know how many were taken out. So the x is 7 divided by 2. Go in there 3 times, 1 left over. Okay, and then 8 divided by 2 is 4, which there is none left over. So there's the answer for that. Okay, number 10, same thing, but now we're divided by 5. Okay, divide by 5, divide by 5. Okay, so when I divide 14 by 5, it can go into there twice, okay, which is 10. So there's how many left over? 4. And then 17 divided by 5 is 3, which is 15, right, with 2. Okay, so now this next one, well, they're all cubes. So we have to break them down first and then look for any like terms, okay? So I'm looking for 3 of something. All of these are 3 of something, not squares. Okay, so if I break down 8, it's 2 and 4 and 2 and 2. So 8 is a perfect cube because there's 3 of them, okay? So a 2 comes out, okay? There was none left over, and there wasn't 3 x's. So that means that that x has to stay there, okay? Nothing can come out of the x's. Okay, so now we do it again. So if I divide this by 3, then that means an x can come out, but there's going to be an x left over, okay? So I have a plus 5, because that 5 is still there. So an x is going to come out, because 4 divided by 3 can go in there one time, but there's still going to be an x left over. Okay? And if that didn't make sense to you, remember you can always do this if you wanted to. Okay, so there's 3 of them, so 1 comes out, but 1 is left over. Next one you can't simplify because there's not 3 of something that can come out, so it's just going to stay the same. Okay, and then same on this one. Okay, nothing can come out because there's not 3 of them. Okay, so now we're looking for like terms with like terms. Okay, so all of these have x's, but now we go to what's in front of them. So what's in front of them, this one's just a whole number. So we're going to look for all the other ones that just have a whole number in front of them, and we're going to combine them. So 2 minus 4 is going to give you a negative 2 cubed root of x. Okay, and then these guys are like terms, just what's in front of them. So the 5x minus 2x is going to give you a positive 3x. And you don't do anything with the radical part. It's just that helps you to find your like terms. Okay, so that's your answer for that. Okay, next one is distributing. Okay, so when we distribute, it's whole number with whole number, radical with radical, and then simplify them if you can. Okay, so a negative 3 rad x times rad x means there's 2 of the rad x. So this would be negative 3 rad x squared. Okay, there's 2 of them. Okay, so when we can simplify this, you need to bring this up. So this would be a negative 3x. Okay, remember this is squared, so I can divide this by 2 and it comes out. Okay, now I'm distributing this. So whole number times whole number is going to give you a negative 27, but now radical with radical, you can't really combine them, so we just write them next to each other. Okay, now we're going to do it again, and we're going to distribute that one, and the numbers in front are 1 times 1, so it's just going to stay as 1. Okay, and then you, again, can't do anything to bring anything out. Okay, so now these two are like terms. So negative 27 and a positive 1 would make it a negative 26 rad xy. Okay, and then we're at our last one, which is taking this one to this one. Okay, which is similar to the first one that we did, okay, where we squared it. Now we have 2 y's. Okay, so it's really a 1 times 9, which is 9, right? And then rad y times rad y is y squared. Well, this can come out, okay, which is now going to just make it a positive 9. Okay, from here, there are no like terms, so we're done. Here's your answer for that. Okay, number 16 is the same as 15, it's just not written out for us, so we take this, and it means to write this parentheses twice. So I have 7 rad x plus 4, and a 7 rad x plus 4. Okay, so distributing whole number would make that 49 rad x squared, right? So it comes out as 49x. Okay, distributing that one times that one, it would make it a positive 28 rad x. And then the same thing here, we get a positive 28 rad x. So they're like terms. So the rad x's when you add are just the like terms. So now you're just going to combine the 28 and the 28. Okay, so that's going to give us 56 rad x. And then a 4 times 4 gives you 60. And again, get to this point. None of them are like this. Okay, so you're done. Okay, next one, number 17. Okay, so we cannot have radicals in the denominator. So in order to do that, you would multiply the top and the bottom by the radical. But if you can, because this will save you time, look first to see if rad with rad, you can actually combine them the way they are. Okay, so if the bottom, because it's a radical with a radical, can go into the top, you're working with smaller numbers. Okay, so 5 can divide into 20. Okay, we're not taking it out of the radical yet. Okay, 5 can go into 20 4 times. Okay, now x's, I have an x on the top and the bottom. Remember, you always move the smaller one to the larger one, okay, and subtract. So that would be x to the second. Okay, now the smaller one to the larger one actually goes down on this one. And again, it's still inside the radical. We haven't done anything with radicals. Okay, this is much easier than trying to multiply this by rad 5x to the 7th, y to the 4th of 5. You're going to have really big numbers, big exponents on your x's. This is easier. Okay, so I need to get rid of the rad y. So in order to do that, I have to multiply the top and the bottom by the radical to get rid of it. Okay, this one can simplify down because 4 is a perfect square. So 4 is a perfect square, which winds up being 2. And this is a perfect square, which just winds up being x because there's 2 of them, right? But this is not a perfect square, so it's just going to stay the same. Okay, then on the bottom, if I were to actually multiply these two, this gives me y squared, and that is a perfect square, which brings it out as a y. And that was the whole goal, is because you cannot have radicals in the denominator. Okay, and we just got rid of it. So now it's done. Okay, number 18, solving equations when you have square roots. So the opposite of square root is to square it. So what I do to one side, I've got to do to the other side. Square gets rid of the square root of both of these. So now, all I have left is that. Okay, so I'm moving the x to the other side, subtracting 5x. Okay, moving that over to the other side, adding 5. So this would make it as x equals. Okay, number 18, almost done with this video, and then we'll go on to the next one. Okay. This one, technically we could solve it and get an answer, but if we were to actually plug it back in, it wouldn't work because there is never going to be where you take the square root and get a negative. Okay, you're not going to get a negative answer. So just so that you understand this. So this is a no solution. So you just need to check your answer. There's your answer. Okay, but if we were to actually process this and go through this, we would square this and square this, which would give me 36. Right? So negative 6 times negative 6 positive 36. Square gets rid of square root, which is x plus 2. And then we move that over, subtract 2, so that would give me 34. Okay, so if I were to plug that back into my original equation, the left side would need to equal the right side and be true. Okay, so that was my original equation. So if I replace the x with 34, 34 plus 2 gives me 36. And does the square root of 36 equal a negative 6? And it would be a no. Okay. All right, next one. Same for that one. When we're trying to get rid of square root, we square it. Well, when we're trying to cube it, we're going to cube root. Okay, cube and cube root get rid of each other. Okay, but now I've got to go 2 times 2, which is 4, times 2, which is 8. Okay, and then move your 3 over to the other side so that x is equal to. Okay, number 21. Okay, same thing, but you can have a negative when you cube. This is not when you square. Okay, so cube this, and cube this. So the cube gets rid of the cube root, which is x minus 2. Okay, and then on the other side, we have a negative times a negative, which is positive times another negative, so it's going to be a negative 125. Okay, and then add 2, so we're really subtracting, which gives me a negative 123. Okay, number 22 asked you to solve for n. So to get the n by itself, we've got to get rid of the 2 first. So this is divide by 2, so I will multiply by 2 and move it to the other side. Okay, so now we're at this. Okay, so I need to get n by itself. In order to get the n by itself, I have to get rid of the radical first. Okay, so this is taking it to the 4th power. So once I take so 4th power here, 4 gets rid of that. What I do to one side, I've got to do to the other side. Okay, well 2 times 2 times 2 times 2 is 16, and m to the 4th equals, and this, the 4th root, got rid of it, still left 5n. So now I'm at my last step. So in order to get n by itself, I have to divide by 5. When I do the one side, I've got to do the other side. So this is your answer for now. Okay, I believe that was it. So I'm going to pause this video, and then the second video will have now 23 through 41.